Okay, so the first shape that we're going to talk about today, we're going to talk about placing figures in the coordinate plane. The first example we're going to look at is a rhombus, and we have N labeled with a y coordinate of B and P labeled 0, A. So if we label our axis, we know that at this point our y value is B, and at this point our x value is A. So we can label our axis. Okay, so the first point that's the easiest one to find is over here at point M. I can get rid of my little question marks. Okay, and M is at the origin. So the origin is always 0, 0. So we can fill those in as 0, 0. Okay, if I go all the way over to A to get here, we know that a rhombus has symmetry. So if I've only gone halfway to A, I've gone A over 2 spaces. So this here, this point would be A over 2. And this one's at the same distance, so that would be A over 2 as well. Okay, next we'll look at our height. We start at B, and so if we go down here, again, because of the symmetry, this would be negative B, and we can fill this in with a B. Our next example is going to be a square. Okay, so we can get rid of this guy. Okay, and we have a square on our coordinate plane, all on the positive axis, and the corners are labeled A, B, C, and D. A is labeled as 0, 0. B is 2 question marks. C is also 2 question marks. And D is labeled X, 0. Okay, so again, we can look at our properties of a square, and as I said before, this is a square. And our properties of a square say that all the sides have to be equal. So if the bottom side is X, then this side has to be X, this side has to be X, and that side has to be X. So my X coordinate here would be X, and my Y coordinate here would also have to be X. Now notice here, when I do any point on this x-axis has a y value of 0. Both the origin and this point have a y value of 0. Anything on the y-axis has an x coordinate of 0. So if I'm looking at this point, I've gone over 0 spaces, which means we have a 0 for the x coordinate, and then I've gone up x spaces. For C, we can also find that based off the values we have so far. We're going over x spaces and up x spaces. So those would be the corners of our square: 0, 0, 0x, x, x, and x, 0. Let's look at another square and try a second one. Okay. So our second square is actually going to be in the 4th quadrant. Okay, and it's labeled QRST. So Q is at 0, 0. R is A, 0. S is blank. And T is also blank. Okay, so we take a look at this and we say, okay, we've gone from 0 to A on the x-axis, which means the length of our square is going to be A on all sides. Since it's A on all sides, if I'm going to go to this point down here, I have to have a length of A, but we're going down A, so we're going to call this negative A for the height. And again, it's on the y-axis, so we put a 0 for the x value. So we've gone over 0, but we've gone down a spaces. And then for our last point S, we go over a spaces and down a. So it would be a, negative a for the corner. Okay. So let's try a different shape. Let's do a nice parallelogram. Okay, so for a parallelogram, our corners are going to be PQRO. And again, it's going to be in the first quadrant, all positive. And it will be leaning to this side. Okay, P is up here, and P is labeled KM. Q is blank. R is X0. And O is 0, 0 at the origin. Okay. So we're going to go ahead and label all of our values. So we know that our X value here is at K. Our X value here is X. And we know that our Y value here is M. Okay. So we're looking for Q up here, and the easier one is the Y value to find. The Y value is M, that has the same height as the other one. So this X value is a little bit more complicated than the other one. Not a lot more complicated, but a little bit. So we take this and we split it off into sections. And remember, just like any other shape, we have a lot of symmetry in a parallelogram. So if we've gone K spaces in this part of the triangle, this triangle that looks the same but upside down, this space is also going to be K. So we look at this piece here and the piece at the top, both of those are K spaces. Okay? As we said earlier, this is X right here. This value right here was X. So far we've gone over X spaces. We go over an additional K spaces. So this will be X plus K for that area. So we go over X, we go an additional K spaces to get to our point, and then up M. If that example seems a little confusing to you, let's look at it just on a straight line. Okay? So if I have a straight line that looks like this, and it's separated into several pieces, okay, and I tell you that this piece is X spaces and this space is P spaces, all together we would call that X plus P. Okay. And if we had a piece above that, and this was the same point on the same axis, on the same axis, on the same axis, okay, even without labeling that, we would still know that this was X plus P because it looks like the same length. Okay? And that's kind of what we're looking at with these trapezoid or these parallelograms. All we're doing is adding some diagonals here. Okay, and if I draw my dotted lines, okay, that's what's happening. You're saying that you've gone X spaces here and P spaces here, so all together you've gone over X plus P. It just looks a little bit more confusing because you have these diagonals connecting it and it's harder to see. Okay? We can also look at that in numbers. Sometimes that makes it a little bit easier to see as well. If we have a parallelogram, just like the one we just saw, okay, and I have some coordinates, so we had 0, 0 here, and then KM up here, okay, what we can do, and this was X0 down here, and this was the blank one. Instead of looking at K and M, we could say, okay, I think this is the coordinate 1, 3. Would make k equal to 1, m equal to 3. And then maybe we'll call x 6, for example. Okay? So, if this is 1, 3, this would be 1 on your x-axis. The height would be 3. And then somewhere in here, there would be a 1 and a 2. Okay, and if we went all the way over here, this started at 1, and we're going to end up at 6. So in here we have 2, 3, 4, and 5. Okay, and if we continue on in this direction, again, we have that symmetry. So from here to here, that triangle went 1 space. Okay, and then the whole side was 6 spaces. So again, if we go this whole side plus an extra 1, we've gone 7 spaces in total to get to this point. So we've gone over 7, up 3. And if we look at that in terms of the letters that we used, 7 is the same as 6 plus 1, which is x plus k, and the 3 is the same as our m that we chose. Okay, so sometimes it's just a little bit easier to see in numbers, sometimes it's easier to see in straight lines. Whatever helps you is how you should think about it. I'm just giving you a bunch of different ways to see this. Okay, how about a nice rhombus in a different orientation? Let's look at a rhombus that's drawn vertically. Okay, so we have some points here and some points here, and this is a nice rhombus. Okay, and we have a point 0B, a point A0, a point down here that we don't know, and another point on this side that we don't know. Okay, now remember, when we look at our x-axis, our y value should be 0, so we know that one right away. And when we look at our y-axis, our x value should be 0. So those we can fill in right off the bat since they're on the axes. The next thing we have to figure out is our symmetry here. So if we go up b spaces to get to this dot, that means we need to go down b spaces to get to that spot because they should be the same on both sides. This distance on both sides should be b. Remember, in a rhombus, okay, the diagonals bisect each other. So we have this nice symmetry, so this should be negative b, because instead of going up b, we have gone down b. Same thing on this side. Our symmetry should be the same here, since we've gone from 0 to a on this side. We should go a spaces on that side as well, making this negative a. Okay. Let's look at one that's been given the coordinates but no picture. So we have a quadrilateral with vertices at A, 0, negative A, 0, 0A, and 0, negative A. Okay, so we have all of these points, and our goal is to first make a graph and then identify what it looks like. So here we have, if I go A0, we've gone over A spaces but up none. So this would be A0. For the next one, I'm going to go backwards A because that's my x coordinate, and up 0. So this would be negative A0. The third one, I want to go over none, but up A spaces, so this would be 0A. And for the last one, over 0 spaces, and then down A. So this would be 0, negative A. So we can plot coordinates on a graph with letters just like we do with numbers. Okay, so on your worksheet that you have, Reteaching 6-6, why don't you try 5 and 6 on your own, okay? And if you have any questions, I'll be glad to answer them during class or after school.